So let's take a look at this equation, at this problem. They want us to rewrite this equation in standard form. They want us to make a sketch of this conic section. We know it's a parabola because we only have one variable that's being squared, the y variable. X is not being squared. Um, when I write this in standard form, I like to have my squared term, that variable, on the left-hand side, and everything else on the right-hand side of the equation. Uh, but first I notice that all of these numbers are even numbers. They are all divisible by 2. So I'm going to divide each term by 2 just to get the numbers smaller and really to get that coefficient in front of y squared to equal 1. The problem will generally be easier with completing the square if my leading coefficient is a 1. So if I divide this by 2, divide this term by 2, divide this term by 2, divide this term, and of course when you take 0 and divide it by 2, you still get 0. But to balance the equation, if you do something to one term, you have to do it to all of them. All right, so um, we've got 4 divided by 2 is 2x plus y squared minus 2 and equals 0. Okay, so now let's keep the y's on the left-hand side of the equation. I'm going to give myself a little bit of room so I can complete the square. And these other terms, they change sides of the equation. When a term changes side, it changes sign. If I subtract 2x from the left-hand side, that'll cancel that 2x. But I'll need to subtract 2x from the right-hand side. When I subtract 4 from the left-hand side, the 4 minus 4 will cancel, and I'll have to subtract 4 from the right-hand side. To complete the square, we look at the coefficient in front of the linear term, -2. We take half of -2, which is -1, and we square it, which is +1. By adding that amount, we've now made this trinomial a perfect square. It's easy to factor. We don't have to do the x method. We've got half of -2 is -1. So we've got this binomial squared. I almost forgot just then since I've added 1 on the left-hand side, to add 1 on the right-hand side to balance the equation. So now we have -2x minus 3. I need the coefficient in front of x to be a 1. So I need to factor in -2 from each term. So since 3 is not divisible by 2, I'm just going to write it as a fraction, 3 over 2. When I distribute that to that second term, the negative times a positive will make it negative, and the 2's will cancel, and I'll have that minus 3. All right, so since the y variable was being squared, we know that it was either going to open to the left or to the right. We can use this coefficient in front of the linear term to determine the value of p. Let's identify the vertex. I'm going to write 3/2 as 1.5, but since this is adding, I have to change the sign. So my x coordinate for the vertex is -1.5, -3/2. For the y coordinate, it's 1. I take 4p and set it equal to the coefficient in front of x. Divide both sides by 4, and I see that p is -1/2. I'm going to think of that as -0.5 when I'm adding and subtracting that amount to my vertex to find the other properties of this parabola. So let's come over and make a sketch. Since p is negative, it's going to open to the left because it's y squared. That means left or right. With a negative p, it opens to the left. So I've got a parabola that's going to look like this. It's going to have two lines that are important. The axis of symmetry, because the top portion is a mirror image of the bottom portion. Horizontal lines are of the form y equals. The crucial point, the most important point or interesting point on the parabola is the vertex. There's another point that's not on the graph, but it's that focus. Because these parabolas have the property that if something, they're good in sending and receiving waves and information, like your satellite dishes, your headlights on your car. Something comes into the parabola, hits the surface, and when it bounces off the surface, it all collects at this point they call the focus. All right, now I've got a directrix that is always a line that's perpendicular to my axis of symmetry. This vertical line is going to be of the form x equals something. All right, so we found the vertex to be negative 1.5, comma 1. And if I'm moving to the left or to the right, that's going to change the x-coordinate. I'm just moving 0.5 units. If I move 0.5 units to the left, I'm going to subtract 0.5 away from negative 1.5, and I'll be at negative 2. The y-coordinate is the same. It's 1. This is y equals 1. So you can see those numbers, those three numbers are the same. If I move half a unit to the right of the vertex, if I add 1/2, negative 1.5 plus 0.5, then this is going to be negative 1. So I believe now that I have all 5 pieces of information that they wanted for this problem. We rewrote the equation in standard form. From that standard form, we identified the coordinates of the vertex. We found the value of p. We used that value of p, the sign of it, to determine that the parabola opened to the left. We used the magnitude of it to move left and right from that units from that vertex. To the left of this vertex, we found the coordinates of the focus. To the right of this vertex, we found the equation for a line that they refer to as the directrix. So we've got our focus, we've got the value of p, we've got all 5 things. So I hope that helps, and I'll talk to you later. I might go back to bed. It's early Saturday morning and I'm tired.